Hello. So in chapter 18, we're actually going to take a look at the existential crisis, just to borrow from Bernie Sanders, that actually faces humanity right now, which is that of climate change. Of course, we know we have the current threat of coronavirus, which of course should be taken seriously. But in relation to environmental issues, we have that of climate change currently. This chapter is devoted almost entirely to a discussion of global climate change or the greenhouse effect. In recent years, this problem has been pushed increasingly towards the front burner in terms of both its seriousness and of the steps proposed and used to be taken to address it. The undeniable prospects of the 21st century are for the world to continue to shrink and nations to become more interconnected. Obviously, globalization has become a norm in this 21st century, and we all know that. Regional and global problems now affect almost every single country in the world, and with the 21st century also comes rapid economic and industrial growth. Of course, this leads us to an increase in greenhouse gas emissions, which eventually contributes to climate change. This globalization or interconnectedness mentioned earlier is what environmental economists mean by the global environment. We'll first explore the physical problem of climate change. The underlying principle under climate change is that the increased quantity of greenhouse gases such as carbon dioxide trap the heat from the sun and cause a gradual increase in the Earth's temperature. Greenhouse gases are not at all bad. In fact, they make the Earth habitable. The problem is having too much of them, and that's the problem with having too much of anything, right? According to statistics with no greenhouse gases at all, the Earth will be 30 degrees cooler, making it uninhabitable because we'll all eventually freeze to death, and nobody wants to live on an Earth that is really, really freezing cold. Prior to the Industrial Revolution, the trace amounts of greenhouse gases in the atmosphere were actually in balance, and the Industrial Revolution led to our reliance on fossil fuels and heavy deforestation, which drastically increased the amount of greenhouse gases. Taking a look at this chart, we see the global average temperature relative to the average of the period between 1960 and 1990. The red line, which you see over here, basically shows the average annual temperature through time. We can actually see that the global temperature has risen, or global temperatures have risen over time. When we examine the pre-industrial period around 1850, which is right over here, temperatures were much cooler then, and you can actually see it. Overall, it's been established that global temperature has increased by 1.1 degrees Celsius since the Industrial Revolution. This is not just rooted in the data, but it's actually rooted in research as well. The United Nations has actually concluded there's 95% probability that human activities over the last 50 years have warmed up our planet, okay? And over the last 50 years, let's say from 1940 to 1950, 1960, right? Average temperatures have actually, or global average temperatures have actually been increasing at quite a fast rate. And this is actually concerning. A major contributor of climate change is carbon dioxide, also known as CO2. Did you guys know that CO2 emissions are essentially at their highest levels in over 800,000 years? For the first time, CO2 concentrations are at 400 parts per million, which is very high. Which part of the world produces the most CO2? That is the main question that we need to actually look at. Well, China, North America, and Europe does. However, that's not the best way to actually examine it. We need to look at emissions per capita or per person. Other notable culprits are the United States, who actually produce 16.24 tons per capita, Canada, who actually produce 15.64 tons per person, and Australia, who produce 16.9 tons per person. Earlier on in the semester, we talked about the concept of environmental justice. In fact, the world's poorest contributes less than 1% of CO2 emissions, but unfortunately will be the most vulnerable to climate change impacts through deforestation, rising sea levels, and rising temperatures, and to some extent even droughts. The world's richest have emits about 86% of emissions, but they won't face as much drastic impacts. Unfortunately, things are not that simple. CO2 is not the only gas, as you can see from this chart, that contributes to global warming. Let me use my laser here. Okay. Of course, carbon dioxide contributes a lot, but we see that there's methane, right? And that actually reminds me of Cowspiracy. Oh, I miss you guys so much. right? So that Cowspiracy documentary was good, and you did talk about methane, right? But methane is a problem, but it's not as big as carbon dioxide is. Okay, and we also have nitrous oxide as major culprits of global climate change. Then we have the HFC gases, and HFC basically stands for hydrofluorocarbons. We have the SF6 gases, which is basically sulfur hexafluoride gases. And we have the PFC gases, which is basically perfluorocarbons, right? And all these, although these are quite minute, you can barely see them, contribute to climate change as well. Right, what about the human and ecosystem impacts? Okay, so there'll be rising temperatures over time leading to warmer conditions, climates, and possibly overheating. There will also be changes in precipitation patterns, right? For instance, average US precipitation has increased since 1900. Bird projections into the future showing heavy precipitation will continue. And apart from precipitation increasing, right, the patterns of precipitation will actually be irregular as well due to climate change. Okay, it's also projected that sea levels will rise by 1 to 4 feet by 2100. And we know that rising sea levels could have major impacts on fisheries and societies that rely on marine resources, right? Another impact of climate change is ocean acidification, and ocean acidification comes about due to higher levels of atmospheric CO2. Okay, ocean acidification also will lead to a loss of marine life and coral reefs. Higher temperatures may also put a strain on wildlife or species who will not be able to adjust and hence perish. Okay, so these are the main sort of human and ecosystem impacts of the global climate change. Well, the next question we sort of need to look at is how much worse will global climate change actually get? So scientists have estimated that the probability that global temperature will increase beyond 4 degrees Celsius is 5 to 17%. Others have put this estimate around 23%, which is quite interesting. Regardless, we know temperatures will keep on increasing, and hence we need to put a stop to global warming. So how do we tackle the problem of global warming? Well, there are two fundamental choices, right? So the first one is that of mitigation, and we have the second one of adaptation. So when we say mitigation, basically mitigation refers to taking the necessary measures to reduce greenhouse gas emissions so as to reduce global temperature increases. Okay, so taking the necessary measures today to reduce greenhouse gas emissions and eventually in the future reduce global temperature increases, or to reduce the rate of global temperature increases. Adaptation, on the other hand, involves posterity or future generations coming up with unique ways to reduce the negative impact of climate change, right? So adaptation basically means that you can't do anything about climate change, so you basically have to come up with new technologies or new ways of actually living with climate change. Right, so there's been some technical responses, or we can actually take a look at technical responses in relation to global climate change. Right, so we know that there are abatement costs associated with trying to reduce climate change, and cost effectiveness is something we ought to think about. Right, since CO2 is the major culprit, we focus on reducing CO2 emissions. Okay, so consider the following equation. So we have a simple mathematical equation that sort of looks at total emissions or total CO2 emissions in terms of population, in terms of GDP per person or GDP per capita, in terms of energy as a ratio of GDP, right? And in terms of carbon dioxide as a ratio of energy. So now let's look at the first component. Okay, so population, right? So higher populations use more energy, or a larger number of people use more energy and will lead to higher emissions. Okay, so it actually makes sense for it to be in our equation. Okay, we also have the next one, which is basically GDP per person. Higher economic growth means you're actually producing more, and through production, we know we have emission releases, okay, and higher greenhouse gases. So higher economic growth will actually lead to higher total carbon dioxide emissions into the atmosphere. We have the third one, which is basically energy as a ratio of GDP, which is also known as energy efficiency. So we have energy efficiency. Okay, and that is also known as the amount of energy used per dollar of output. And the last one is basically CO2 as a relation of energy, or as a ratio of energy. Okay, so basically a CO2 per energy used. Okay, so what percentage of your energy levels or energy used, right, is carbon dioxide, or consists of carbon dioxide. Okay, so first of all, let's look at the first two, right? We said, or let's look at the first few components, which is basically population and GDP per person. We said large populations use more energy and will lead to higher emissions. However, we've seen that despite population boom in developing countries, emission rates from those countries are relatively low. Also, population control measures will be highly controversial and problematic. And also, there's no countries willing to reduce economic development. Okay, so actually trying to reduce population won't work. Trying to reduce GDP per person doesn't really make sense, because that's basically diminishing economic growth, and no country is willing to do that. So the two components that we need to focus on in terms of reducing total CO2 emissions, and then reducing climate change and reducing global temperatures, is looking at energy efficiency and basically carbon dioxide per energy, okay, or the percentage of energy that consists of carbon dioxide. Okay, so the key here with energy per GDP or energy efficiency is to move towards levels of production and consumption that require smaller quantities of energy. Okay, so we're trying to improve GDP, right? But we don't want to use as much energy in trying to improve GDP, or GDP should not consist of a lot of energy products. Okay, or even if it does consist of a lot of energy products, those products should basically be renewable, right? And then we have the last one, which is basically CO2 per energy used. And one way we can actually reduce CO2 per energy used, and hence bring a reduction in total CO2 emissions, is basically to actually use more renewable resources that does not consist of carbon dioxide. Okay, so now let's look at the data. So we have the world, we have the United States, and basically we have India, and we have their total CO2 emissions. Of course, the United States has higher CO2 emissions than India, despite the fact that even India has a higher population than the United States. Okay, but this is largely due to the fact that economic growth in the United States is pretty large. Okay, also CO2 as a ratio of energy, right, in the United States is pretty large as well. Hence, the United States will have total CO2 emissions than India. Okay, but I guess the most important thing is looking at the rate of change. Okay, so in terms of energy efficiency, right, it has basically reduced, right? Energy per GDP has basically reduced in the world, and CO2 as a percentage of energy has also reduced in the world. Okay, energy as a percentage of GDP, or as a ratio of GDP, has reduced in the United States. Okay, but there's no rate of change in terms of CO2 as a percentage of energy. And for India, on the other hand, since it's an emerging country and the developing country is still growing, right? So energy as a relation of GDP has actually increased, okay? And CO2 as a percentage of energy has basically increased, but it's really minuscule, or it's really minute, so it's not that much of an effect. But it's pretty interesting to see the rates of change, right? So the main thing is that you're trying to sort of bring these down, energy as a percentage of GDP and CO2 as a percentage of energy. And basically the world is doing that, which is commendable and is good to see, and the United States is doing that as well. Right, so that is sort of like a simple model that basically links population, GDP per person, energy as a percentage of GDP, and CO2 as a percentage of total energy used in relation to the total CO2 emissions. We also have incentive-based strategies, and these have been a major way of reducing climate change. So countries of the EU, for example, so we basically have two incentive-based strategies. We have the carbon tax and we have cap and trade. And with cap and trade, countries of the EU have instituted a large inter-country cap and trade program targeting CO2 emissions. In the agreement, the EU agreed to reduce CO2 emissions to a level 7% below its 1990 emissions, We also have carbon tax, and we already saw what carbon tax is. So basically, you charge firms an extra amount for excessive carbon emissions or for how much carbon emissions they basically emit. Or you could actually create subsidies so firms use renewable energy or cleaner sources of energy to reduce CO2 emissions, right? So carbon tax, right, and cap and trade is basically to reduce CO2 emissions. We also have international efforts in global warming, and the major one, which we'll take a look at, is the Kyoto Protocol. The major focal point for international reductions in greenhouse gas emissions has been the Kyoto Protocol under the auspices of the United Nations Framework on Climate Change, which is also known as the UNFCCC, right? So the Kyoto Protocol basically initially started in 1997, although some minor changes were made in 2005. Industrialized countries mainly were to limit and reduce greenhouse gas emissions in accordance with agreed individual targets. The convention itself only asks those countries to adopt policies and measures on mitigation to report periodically, and it also binds developed countries and places a heavier burden on them. Another principle of what we call common by differentiated responsibility and respective capabilities, because it recognizes that they are largely responsible. So largely responsible they are. So the they being developed countries, they are largely responsible for the current high levels of GHG, which is basically greenhouse gas emissions in the atmosphere, right? So international emissions trading is part of 3 market-based systems that the Kyoto Protocol basically uses, right, in trying to reduce global warming, right? And basically, the international emissions trading allows countries that have emission units to spare to sell this excess capacity to countries that are over their targets. Okay, so by using carbon as a common commodity, it gives the firms an incentive to reduce carbon emissions in order to have emission units to actually sell. And then you also have another market-based system, which is the Clean Development Mechanism. And this allows countries with an emission reduction commitment to create emission reduction projects in developing countries. Okay, so then there's some sort of environmental justice being done over there. And then finally, you have the joint implementation. Right, and basically with the joint implementation allows a country with an emission reduction or limitation commitment under the Kyoto Protocol to earn emission reduction units. Okay. The Kyoto Protocol also established a rigorous monitoring, review, and verification system. Sorry about that. As well as a compliance system to basically ensure transparency and to hold all the parties under it to some sort of account. Under the protocol, countries' actual emissions usually have to be monitored. And this is done by the UN, and precise records have to be kept of the trades generally carried out. So when we say the trades, we're talking about the international emissions trading system. Okay. The Kyoto Protocol is not necessarily foolproof or is not necessarily perfect. It has a couple of deficiencies. For one, so the first deficiency we actually take a look at. The objectives were not specific enough. Okay, so basically it was not specific in terms of atmospheric carbon content, or it was not specific in sort of specifying terms of atmospheric carbon content, and future increases in global temperature. So there's no specific objectives it was trying to meet. It was just trying to reduce carbon dioxide emissions, but I didn't really say by how much. Second, the Kyoto Protocol. Sorry, I was gonna say principle, but the Kyoto Protocol also did not involve developing countries. Several of which are becoming sort of major corporates of emitting greenhouse gases due to the fact that majority of them are actually growing. And that's one deficiency. And majority of the goals set were actually too short term and not too long term. They weren't really looking into the future. But they had this problem of short termism. So those are some of the deficiencies. Experts sort of argue about the Kyoto Protocol. And of course, given the deficiencies it had, it basically was amended, and the amendment was it wasn't really amended, but there's sort of a new agreement that was put into place. And this has to do with the Paris Agreement or the Paris Accord. Okay, so the Paris Agreement of 2015, basically what it does is that it brings all nations into a common cause and undertake ambitious efforts, or to undertake certain efforts to basically combat climate change and adapt to its effects, which is really important. So remember we talked about adaptation, for instance, and that is what the Paris Agreement has included, that the Kyoto Protocol basically essentially didn't have, right? So the Paris Accord looks at mitigation and also adaptation. It's also included developing countries in it. So it's not just about developed countries, but it's all inclusive of developing countries as well. And it's sort of put up this support mechanism framework to assist developing countries to try and reduce global warming as well. So it's basically sort of charts a new course in the global climate effort. And this central sort of objective or aim is to strengthen the global response to the threat of climate change by at least keeping a global temperature rise in this century, which is basically the 21st century, well below 2 degrees Celsius. Something the Kyoto Protocol doesn't really do or doesn't really look at. And basically it tries to also pursue efforts to limit temperature increase even further to 1.5 degrees Celsius. Additionally, the agreement basically tries to strengthen the ability of countries to deal with the impacts of climate change. And to reach these ambitious goals, they've put in place appropriate financial flows, right? So financial flows mainly from developed countries to developing countries to assist them in reducing carbon emissions, developing new technology to actually reduce carbon emissions, or to develop new projects to actually reduce carbon emissions. They've also put in place a new technology framework where they actually do research and development to actually come up with more renewable ways of or more renewable energy, or more sort of efficient ways of production, right? And also they trying to support developing countries mainly, or vulnerable countries who actually face climate change, in terms of actually coming up with their own sort of national objectives, which will basically work for them. Because one thing you need to think about is that on the global scale, many countries basically have different objectives. At the same time, many countries basically have different rates of emissions. So it's difficult to actually sort of have a uniform objective for all of them, right? So to actually do this, they're actually looking at the national level as well, for these countries to come up with their own national objectives and to actually come up with a more efficient sort of way of reducing emission rates and not sort of jeopardizing the economy or jeopardizing the welfare of their country at the same time. Okay, so guys, I know chapter 18 was pretty short. I'll actually end the lecture here. This is going to be the last lecture of the semester. There isn't going to be any homework on chapter 18, but guys, I implore you to read a book. You have more details there. I think chapter 18 is pretty straightforward read. It doesn't have too much technicalities, but again, guys, if you don't understand anything or you're confused about something, please do not hesitate to ask me a question. I really miss you guys. Online teaching or recording videos have been, recording video lectures have been quite stressful. It's not the same if I don't see you around. I don't have the same energy to be honest. But hopefully these videos have been useful, and thank you very much for making class a really successful one. Okay, I'll see you guys later, and most importantly, stay safe.